One of the rides at a carnival involves a cabin being oscillated around a center position with simple harmonic motion. The period of the motion is always 1.5 minutes, but the amplitude can be adjusted. There is a built-in safety feature that turns off the power when the speed reaches 80 meters per minute. Determine the maximum possible amplitude of the motion. The maximum speed is always omega A. We also know that t is equal to 2 pi over omega. The period is fixed at 1.5. So 1.5 is equal to 2 pi over omega. Therefore omega is 2 pi divided by 1.5. So omega is going to be 4 pi by 3. Vmax needs to be 80. So 80 is equal to 4 pi by 3a. Rearranging, a is going to be 3 times 80 divided by 4 pi. And calculating that gives us 19.10 meters. If the amplitude was set at 12 meters, for what percentage of the time would the speed of the cabin be greater than half the maximum speed stated in part A above? The maximum speed above was 80, so half of this would be 40. Let's consider the SHM. So the amplitude is set at 12. From here it's going to go outwards, and at some stage here it will reach this speed of 40, and we want to know how long that takes. It will then be below 40 from here to here. It will be back above 40 until it reaches the symmetric point on the other side, and then slower here. So if we work out the time here, all we need to do is multiply it by 4, because it's above 40 when it does this, 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 and this during one motion. If we're starting at the center, we could say that x is equal to 12 sine omega t. Remember, 12 is the amplitude, and we know from above that omega is equal to 4 pi by 3, or 2 pi by 1.5. So V is going to be 12 omega cos omega t, and we want that to be equal to 40. So we can solve this on the calculator. So we want to solve. Need to make sure we're in radians. 12 times 4 pi by 3 times cos and then in here we're going to need, again, we're going to need omega, which is 4 pi by 3 and times what we're trying to find, which is x, and we want that to be equal to 40. To execute, and ignoring a lot of this stuff, we can see that it's 0.1553. Now remember, that's just the time for it to go from the center to here, and it's going to be in that part of the motion 4 times in one oscillation. So we need to do 4 times the 0.1553 divided by the entire period, and then just multiply by 100 to turn it into a percentage. So we're taking this value here, we're going to times it by 4, we're going to divide that by 1.5, and we're going to times that by 100, and that gives us 41.4%. On a certain day, the amplitude is set to 6 meters, but the cabin is observed at t equals 0 to be at x equals 3 and moving away from the center of motion. Derive an expression for the displacement of the cabin from the center at time t minutes later. So what we're saying is that this is the center of motion. The amplitude is 6. So we could start off with x equals 6 sine. Then we know that omega is equal to 4 over 3 pi, and that's got to be in here. So that's going to be 4 over 3 pi t. But it starts here, going this way. Now we know that sine of pi by 6 radians, or 30 degrees, is a half. So when t is 0, we want the angle in here to be pi by 6. Then we have 6 times a half, which is 3, and it will be going in the correct direction, because if we differentiate that, we're going to get 6 times 4 over 3 pi cos of the same thing, and that means it will be going in the positive direction at pi by 6, because cos of pi by 6 is positive, so this would be the expression.